About the double substitute question, I actually have more thing to say, but I don't want to to edit my video, so I will record a new one. So it's still that box, and remember from last time, these are the Pareto efficient set, and then the first person, I mean person A, its utility function is this, and person B's utility function is this. So one problem to think about is, suppose we have endowment here. So suppose our omega is here. What would be the competitive equilibrium? So the obvious thing is the opposite of what we just did, which is the price equal to 1 case. Obviously it should be here, and then think about it. So the first person would want to maximize and hit this point. Right? So the first person's budget is below this line, so we want to maximize this thing. We move this up until we hit this. This is the highest point it can hit. It's not, again, obviously it's not this point, it's the other point. So let me erase all the useless stuff. So that's our demand, and for the other person, similar reason, this is the feasible set. I want to push my utility function, which looks like the other. So my utility function looks like this, so I want to push it as far as possible, so the furthest one is this. So still, both of us want this point, so it's very good. So this is actually a competitive equilibrium. But then if we change price, we can see that when we change price, it still works. So if the price is like this, think again, if the price is like this, for the first person, I have this utility I want to push that way. I still want to end up this point, right? So we're still here. For the second person, we're like this, and if we push this way, we still want to be here. So it's still okay. So the price ratio is actually different. So the price ratio, if we do it this way, it's also, if you do it carefully, it's also we still want to be at this point. So that's actually very surprising. There can be multiple competitive equilibria. There actually can be multiple points. There can be multiple allocations. One example is the mistake that I made about the double quasi-linear one, which is question 3. So the original question 3 question, which is too hard, it has multiple prices and multiple allocations as competitive equilibrium. This one, however, it has multiple competitive equilibrium in terms of prices. So any price between half and 2. If it's not, I'll show you later as well. And then we have this, I will write it as A has 0x, B has, A has 10y, so I'll stop there. So all these things, all of them are competitive, and there are different ones because they have different prices. So if you have price ratio that's like this, then it's a different story. So let me remove the other useless lines. So if the price ratio is like this, when we actually maximize this blue line, so remember the blue line is shaped this way, when we want to maximize it, we don't hit this line. This will be extended like very, very far, and then this blue line will be, can go very, very far as well. Basically we want to be here. So this is the demand of the first person. The drawing is very bad, but you basically, you see the point. So the price needs to be within this range, but any price will support this point as the competitive equilibrium. So that's multiple competitive equilibrium is possible, firstly, and as I said, it's even possible for different allocations to be competitive equilibrium. So now we have seen places where there's no competitive equilibrium. There's one, there are multiple, there are infinite number of them. So basically anything is possible.